On August 30th, 2026, NASA will launch a telescope so powerful it could fundamentally rewrite our understanding of the universe. It is called the Nancy Grace Roman Space Telescope, and it has a field of view 100 times larger than the Hubble Space Telescope. It will hunt for thousands of exoplanets, probe the mysterious force of dark energy, and search for distant black holes that shred stars. And it is launching on a SpaceX Falcon Heavy from the same pad that sent Apollo astronauts to the moon. Welcome to TrendForge. Today we are breaking down everything you need to know about NASA's next flagship mission, the Nancy Grace Roman Space Telescope, and why it matters for the future of astronomy. Let's get into it. The Nancy Grace Roman Space Telescope, or Roman for short, is NASA's next big flagship space telescope. Construction was completed on November 25, 2025, and it is now scheduled to launch on August 30th, 2026. It is named after Dr. Nancy Grace Roman, who was NASA's first chief of astronomy and is often called the mother of Hubble. She championed the idea of a space-based telescope long before most people thought it was possible. Naming this observatory after her is a fitting tribute to a pioneer who helped open the cosmos to humanity. Roman is an infrared space telescope, meaning it sees light that is beyond what human eyes can detect. It is based on a 2.4-meter primary mirror, the same size as the Hubble Space Telescope's mirror. But here is the key difference. Roman was donated to NASA by the National Reconnaissance Office, the agency that operates America's spy satellites. In 2012, the NRO offered to donate 2 surplus telescopes to NASA. These mirrors were designed for looking down at Earth, but NASA repurposed them for looking out into the cosmos. The shorter focal length of the NRO design gives Roman a much wider field of view than Hubble, which is exactly what makes it so powerful. Roman carries 2 main scientific instruments, and both are remarkable. The first is the Wide Field Instrument, or WFI. This is a 300.8 megapixel multiband camera that covers visible and near-infrared wavelengths. To put that in perspective, it provides image sharpness comparable to Hubble, but over a field of view that is 100 times larger. Think of it this way. If Hubble is like looking at the universe through a telescope, Roman is like looking at it through a panoramic camera. Roman will capture enormous cosmic panoramas, surveys of the sky that would take Hubble centuries to complete. The second instrument is the coronagraph instrument, or CGI. This is a technology demonstration that uses novel starlight suppression technology to directly image exoplanets. By blocking out the blinding light of a host star, the coronagraph can reveal planets orbiting that star. This is incredibly difficult to do, and Roman's coronagraph is designed to push the boundaries of what is possible, paving the way for future missions that could image Earth-like planets around other stars. Roman has a 5-year primary mission, with potentially enough fuel to support an additional 5 years for an extended mission. And in those years, it will tackle some of the biggest questions in astrophysics. First, dark energy. Dark energy is the mysterious force causing the universe to expand faster over time. Nobody knows what it is. It makes up about 70% of the universe, and we cannot directly observe it. Roman will study the effects of dark energy by mapping the distribution of galaxies across cosmic time, helping scientists understand how this force has shaped the growth of cosmic structure. It will probe the consistency of general relativity and the curvature of space-time itself. Second, exoplanets. Roman will search for extrasolar planets using a technique called gravitational microlensing. When a star passes in front of a more distant star, its gravity can bend and magnify the light from the background star.